there's this really neat problem about four-dimensional cubes that I want to talk about. So first let's go to three-dimensional cubes. And by the way, in case you're wondering, this app I have on my screen is called Obsidian. It's for making notes, and they added this functionality recently to use flowcharts, and I really like it. But anyway, back to the topic at hand. So if you take a three-dimensional cube, imagine you got a box from Amazon or online, and then you open this box up to see what's inside. And you can open it in a way that all the faces stay connected to each other, and then you rotate them onto the floor, and they form this two-dimensional mesh. So what you're seeing here is one way to do it, and it turns out that there are 11 distinct meshes for the three-dimensional cube. Again, none of the faces overlap with each other, and you can see all the faces, and all the faces are connected to each other. Now, at first I thought that if you take a four-dimensional cube and then take its two-dimensional faces and lay them flat on a table, it would be impossible to do that in a way that none of the faces fall on top of each other. But I was wrong. It's totally possible to do that, as we can see here. So I'll move to a higher resolution image of this. So here you can see a four-dimensional cube. It's composed of 8 three-dimensional cubes. You can kind of count them. Here's one, here's another one, and then here's another cube connecting the different faces, etc. So there'll be 8 cubes in there. And now we can start taking the faces apart and laying them flat on the floor. It seems like the faces are getting disconnected from each other, but it's possible to do these rotations in a way that the faces stay connected to each other. And you can see that eventually all the faces fall down onto the 2D floor, and none of the faces overlap with each other. So you can count 24 faces here, all 24 faces of the four-dimensional cube. And then the question becomes, if there were 11 such meshes for the three-dimensional cube, then how many meshes are there for the four-dimensional cube? Here's one, and I've been counting these meshes up, and I've counted about 1,000 so far, so it's definitely more than 1,000. But I have a strong suspicion that no human being knows the answer to this question yet. I am working on it, and I'll make some follow-up videos, but just wanted to share this really interesting problem about four-dimensional cubes.